Should we still be using a green pure tungsten while we're TIG welding aluminum? It depends on what kind of machine you have. Chances are very good that you've got a modern day machine, especially with the availability and affordability of the TIG machines that places like Harbor Freight are putting out. So if you've got a modern day machine, it's probably got an inverter on it, and that means that you've got a lot more fine control at your fingertips to customize the arc coming out of that machine that we used to have. People my age and a little bit older than us, we were taught to use a pure tungsten on all of our machines, and that's likely because we either learned on the older transformer style machines or were taught by instructors who learned on the older transformer style machines. What do the transformers do that our modern day inverters don't do? Actually, they can do it. The current coming into your shop, into your house, any of that is alternating current, AC current, which is what we use for TIG welding, but it's 60 hertz. That's all you get. With the transformers, you get what you get. You had to weld with it, and it wasn't always a nice, stable, clean, consistent arc. And that's what the balling at the end of the tungsten, pure tungsten electrode used to do. This used to do the work of cleaning up the inconsistencies and roughness in that AC current coming right out of your wall. That was the advantage of having a balled up tungsten instead of sharp one, because most of us who have done DC welding on steel know that a nice sharp tungsten tip focuses all your energy and heat into one little area, keeps a nice little narrow bead. You can control everything more with more of a point. That doesn't change when aluminum welding. You just couldn't do it because you had to have a ball on the end of your tungsten, and pure was best for that. It's kind of like having an aircraft with a blunted nose being able to handle turbulence. You know, it is not going to be very efficient, but it is going to cut through that turbulence a lot better than like a pointy nose on an aircraft going through it. But what our modern day inverter machines allow you to do is manually adjust a custom arc with the frequency and the balance the way you want it to have. The balance is how much time it's spent on the negative side versus the positive side, whether you want more penetration or cleaning action. And then the frequency is how often the arc changes back and forth. If you turn the frequency way down, it'll weld a lot more like those old transformer machines did. And if you turn the frequency on your arc up, you get more of a focused, concentrated beam doing the work where you want it to be done. Does that mean scrap, throw away your pure tungsten? No, I've got a box and a half of it here. It's just not the first thing I reach for anymore because my machine's an inverter, and the purple tungsten, the rare earth, the E3, hold a point much better, and that's what we want. We want it to hold a point as long as your settings are correct. Your settings matter more than anything else. And for anyone else wondering, I'm just reinforcing, this is just an electrode. That's the first thing you learn about TIG welding. This is a non-consumable, ideally, electrode. It has nothing to do with the material you're welding. It's not a filler rod. You want to make sure that your filler rod matches your parent metal. If you're doing code work, if you're doing proper welding, the tungsten doesn't get fed into it. It doesn't have a whole lot to do with the actual material you're working on. This just carries the arc, only carries the arc. So we're not talking about material with these. We're talking about the current passing through them to weld the material. And so you have to talk about the machine carrying the current. And the machines today are much different than the machines we started welding aluminum on AC. Really important when you're aluminum welding to get an electrode that resists contamination and resists balling in the case of our inverters, which is the purple one these days, or the white ones, or the lanthanated, whatever color that is. Lanthanated is more of a DC one direction current, and that keeps a point really well and focuses the beam very carefully. Another advantage to the purple is it starts and maintains the arc a lot better. There's a lot less wander in the arc across the puddle when you have the ball on the end of your tungsten. If you've welded with a ball on the end of your tungsten on AC versus a pointed AC current while welding aluminum, the point will kind of put that arc where it needs to be, and I've seen the arc wander off the end of the ball on the end of a pure tungsten. That's it. That's why it was a hard sell for me too, until I understood the science and the physics behind how the current in the machines work, and now I reach for the purple. But like I said, I still keep the green just in case I have an old machine, or I go somewhere on a job site and I have to use their machine, or I have to do a field repair, or if I'm out of purple tungsten, this will still work. This still works in a pinch. It's just not the first thing that we're grabbing for anymore.